All right. Now, vertical asymptotes. How do we calculate or determine the vertical asymptotes? Again, let's say we have a polynomial function p of x over q of x. Okay. So, if let's say when you are substituting a in numerator and denominator, if you get 0 for denominator but a number in numerator, then those a values are the equations of the vertical asymptotes. Okay, so let's say you have x plus 1 over x minus 1. So basically whatever makes your denominator 0, but if that number makes numerator 0 as well, then you don't get a vertical asymptote but a whole, right? If you have, let's say, x minus 1 over x minus x plus, we had this example, right? If you have x plus 1 times x minus 1 over x minus 1, okay, so you see that 1 makes denominator 0, but you don't have a vertical asymptote at x equals 1, but you have a whole. But if you have only, let's say, x plus 1 over x minus 1, okay, so when x is 1, you get 0 for denominator, but not 0 for numerator. In that case, you have a vertical asymptote at x equals 1. Okay, that's how you get the vertical asymptotes. So basically, you factor numerator, you factor denominator. If you have the same factor, you have a whole. Okay, at that point. If you don't have a same factor for numerator and denominator, but you check the factors of the denominator, and whatever makes them 0, those are your vertical asymptotes. Okay. So the function f of x, now we are going to look at the horizontal asymptotes. For horizontal asymptotes, we have 3 cases. Okay. Now please pay attention. So let's say we have again a rational function p of x over q of x. Okay. So for case 1, if the degree of numerator is less than the degree of denominator, there is a horizontal asymptote at y equals 0. That is case 1. Okay, so maybe we can take a note. So for case 1, degree of numerator is less than the degree of denominator. So I'm just going to put an example here, okay, for case 1. So let's say you have x over x squared plus 1. Okay, so if this is the case, as you see, degree of numerator is 1, degree of denominator is 2. So degree of numerator is less than the degree of denominator. So if that is the case, the horizontal asymptote is located at y equals 0. Okay. So now let's look at case 2. If the degree of numerator is same as the degree of denominator, then you have a horizontal asymptote. This is how you get it. You take the ratio of the leading coefficients. Okay, let's say you have this. Y equals 3x squared plus 1 over 4x squared minus 3. Okay, so you check the degree. So numerator degree 2, denominator degree 2. So they have the same degree. Thank you. Okay, then how do you get the horizontal asymptote? You take the ratio of the leading coefficients. So this is going to be y equals 3 over 4. Okay. Case 3, if you have again a rational function but degree of numerator is 1 more than degree of denominator, then you have an oblique asymptote. Oblique asymptote, you haven't seen it until now, okay? But instead of horizontal asymptote like this, you will have an asymptote that has a slope. Okay, it's not a horizontal line, but it's another line that has a slope, certain slope, or this way, doesn't matter. Okay, so that is case 3. So let me give you an example. Let's say you have x cubed over x squared minus 1. Okay, so in this case you don't have a horizontal asymptote, but you have an oblique asymptote, right? And when we look at the case 3, we are going to see how to get it, but basically we divide the numerator by denominator, and the quotient will be the equation of the oblique asymptote. Okay, so if the degree of numerator, when you compare degree of numerator with degree of denominator, and degree of numerator is more than 1 compared to degree of denominator, then you don't have a horizontal asymptote, you don't have an oblique asymptote. Okay, so those are the 3 cases. So let's look at case 1. Okay, now we are checking if the degree of numerator is less than the degree of denominator, the horizontal asymptote is equal to 0. Okay, example, let's say you have 3 over x minus 1, degree of numerator is 0, degree of denominator is 1, so then you have a horizontal asymptote at y equals 0. Now we are going to sketch the following graphs. Again, what are we going to do when we are sketching? We are going to use x-intercept, y-intercept, asymptotes, and if necessary, positive and negative intervals. Okay, so x-intercept. How do you get the x-intercept? You look at the zeros of the numerator. So what do you have here? Can you make numerator equal to 0? It is 3. You cannot, right? So no x-intercept. Y-intercept. You substitute 0 for x, right? For x-intercept you substitute 0 for y, and for y-intercept you substitute 0 for x. What do you get? 3 over negative 2. So this is your y-intercept. Okay, so negative 3 over 2. Vertical asymptote, we just discussed this, right? So you look at the zeros of the denominator. So look at the denominator. What makes it 0? 2. So you have x equals 2. Now horizontal asymptote. So degree of numerator is 0. Degree of denominator is 1. So degree of numerator is less than degree of denominator. So you have a horizontal asymptote at y equals 0. Okay. So let's put those in our graph. So we have a vertical asymptote at 2. Okay. Horizontal asymptote at y equals 0. On the evaluation, please label your asymptotes. Okay. Make sure you label them. Not only draw, but label. Okay. Then no x-intercept, but y-intercept is negative 3 over 2, so negative 1.5 is here. So actually you are familiar with this graph. You already know how this one looks like from grade 11, right? So 1 over x function, but it has some transformations. So you know that you will have 2 branches, either here, right, or here. But if you have already y-intercept here, if you have to use this point, you know that it's gonna look like this. Okay. But I'm also going to show positive negative intervals. Okay, but if the graph is so simple, you just don't need to do the positive negative intervals. But let's say you want to make sure and you want to do it. So you take, it is like solving rational inequalities. Okay, so look at the zeros of numerator and denominator. So we see that 2 is the 0 of the denominator, no zeros coming from numerator. So you put the 2 in your factor table, and so take all the factors. So this is positive 3, and positive numbers do not affect, has no effect in the factor table, so I'm not going to take it. I'm just going to take the x minus 2 here. So it is 0 here, negative before, positive after. Okay, so looks like when x is less than 2, function is negative. When x is less than 2, function is gonna be below the x-axis. So you're gonna draw it here. Okay, so when x is greater than 2, function is positive. So it's gonna be here. Is there a point? Is there a special point? So for this kind of graphs, we are not going to take special points. We are only going to take x-intercepts and y-intercepts and asymptotes. Okay, but you need to make sure that if function has to be negative, make sure your graph is below x-axis. Okay, if the function is positive, and then you have to stay above the x-axis. But you don't need another point here in this case. Okay, let's look at the next one. We have x plus 5 over x squared minus 4. Let's factor this. Again, we need the same information. We need x-intercepts, y-intercept, vertical asymptote, and horizontal asymptote. X-intercept. So some of you may get confused. Maybe you may want to take a note. Okay, the zeros of numerator gives you x-intercepts. Zeros of the denominator, okay, give you vertical asymptote. Zeros of the numerator, x-intercepts, zeros of the denominator, vertical asymptotes. Okay, then based on that, what is the x-intercept? Negative 5, correct? Whatever makes numerator 0, which is negative 5. So that is your x-intercept. Y-intercept, so you substitute 0 for x. What do you get? 5 over negative 4. So negative 5 over 4. Vertical asymptote, we just said zeros of the denominator. That gives you x equals 2, x equals negative 2. And horizontal asymptote, so you check the degree. So degree of numerator is 1, degree of denominator is 2, degree of numerator is less than the degree of denominator, so you have a horizontal asymptote at y equals 0. Now let's put those information on the graph. Okay, so we have vertical asymptote at 2, make sure you label. Another vertical asymptote at x equals negative 2. We have a horizontal asymptote at y equals 0. Okay, so x-intercept negative 5, we have y-intercept negative 5 over 4, so it is negative 1.25. Okay, so for this one, let's make negative positive intervals. Okay, so we need zeros of numerator and denominator. So we have negative 5, 2, negative 2. Put them in order from smallest to largest. So negative 5, negative 2, positive 2. So the factors are x plus 5, x plus 2, x minus 2. So x plus 5, 0 at negative 5, negative before that and positive after. X plus 2, 0 at negative 2, negative before and positive after. X minus 2 is 0 at 2, negative before, positive after. So now finish the factor table. Negative, positive, negative and positive. Okay, I'm gonna start from very right side. Okay, so when x is greater than 2, f of x is positive. So you only have two chances, right? Either here or there. Oh, by the way, let's not forget, I mentioned that during chapter 1. So you cannot pass through the vertical asymptotes, but you can pass through the horizontal asymptotes. Okay. But here, so a function has to be what? Positive. So you need to stay above the x-axis when x is greater than 2. So you just do this, right? Because you have to use the vertical asymptote, you have to use the horizontal asymptote, and the rational functions that you will see in the advanced functions, if you have a horizontal asymptote, both ends of the graph will approach to the horizontal asymptote. Okay. For example, you have seen before, like exponential functions. So exponential functions only reach the asymptote at one end, right? Not on the other. But for the rational functions that you see, both ends will approach the horizontal asymptotes. Okay. So having said that, let's move on. So we did this part. Now we are between negative 2 and 2. Okay. So the function is negative. So you have to stay below the x-axis when you are sketching. And make sure you use that point, the y-intercept that we marked. Again, approach the asymptotes. So now we are between negative 5 and negative 2. The function is positive. Between negative 5 and negative 2, it is positive. So you have to stay above x-axis and you have to use the vertical asymptote. Okay. And the next is less than negative 5. It is below the x-axis. Okay. So your graph is gonna be below, but should I just do this? Is this okay? No, because I just mentioned that, you know, if you have a horizontal asymptote for the rational functions at this level, okay, so both ends are approaching to that, so then I cannot just go there. I have to come back to the asymptote. Okay, then I'm gonna just do a little bump and come back to the horizontal asymptote.